Hi guys, good evening. No guys, the class is from 5 to 8. This is 3 hour batch, I suppose. Uh, no particular magazine required for geography. Good evening all. Inner planets are called as terrestrial planets because they look like Earth. Outer planets are called as gaseous planets, right? Jupiter is an example. And when we talk about inner planets, terrestrial planets, they are rocky planets. Okay, so the surface of all these are hard enough. That's the reason we call them as atmosphere and all comes under climatology itself. All of these were molten magma. Once solar wind removed primordial atmosphere, they all started cooling similar to the Earth. So, as they are similar to Earth, we call it as terrestrial planets. We normally say that outer planets has lot of gases, guys. We do not know much about the interior and other parts of outer planets. Yeah, Gayatri, as I told, Anjali, early atmosphere basically means after degassing. Okay, after degassing, those were present. Yeah, Faisal, that's true. Okay. Hariharan, uh, any hot object, when it cools, okay, when it cools, it releases the heat. So in such a case, if any gases are there that come out, if you have living organisms, especially anaerobic organisms, you will normally ensure that, the way plants has, okay, the way plants has, if you look at that, that's enough. Okay. Outer planets are called as gaseous planets because Jovian planets, because they are similar to Jupiter. Inner planets are considered to be similar to Earth. Outer planets are considered similar to Jupiter. Climatology. Evolution of stars and all are not important. Yeah. So, guys, as many have joined, let me tell you certain things here. See, first basic thing is whatever printed content is there on the slides, okay, that is different. But first, every day in the class, whatever I teach you, right, focus on that particular part. Later, we will read the other parts as well. Every word that is there in the syllabus, every word that is there in standard books and NCRT will be covered, but the flow will be different. So many students were asking, what should we do immediately after the class? See, the first thing that I want you people to know is, yeah, class notes means whatever is written here is, okay, whatever is written here, not the slides. Okay, I want everyone to write down along with me so that you have clarity and you have your own handwritten notes. Second, along with this, what is important for me is NCERTs. Okay, you have to see NCERT. And yesterday's topic, I told you 11th standard NCERT. I want you to read the same aspect, nothing more than that. Okay. Can we use colored pens while drawing diagram in the exam? Here you can do this, but not in the exam. In the exam is not permitted. Okay. Okay. So, one last thing I want you to know is, guys, there will be a lot of continuity in the class. Okay. If you don't attend one lecture, there is high possibility you won't understand the next lecture. So it's my sincere request to you all that if you face any problem, please try to cover it up so that it's easy for you when you attend next topic. Geography is technical and it is interconnected. As you saw yesterday, there will be a flow. If flow is missed, you won't understand next classes. Let's say you don't attend today, tomorrow's class will be very difficult for you. And you will feel the topic is not clearly relatable. So, clearly, I'm telling you again and again, please ensure the regularity of your attendance in the class. No need of any standard books, guys. Yes. So, guys, let's get into the topic. The next subheading that we are going to study is about pressure and temperature. So, we are going to study about pressure and temperature. Everyone, I just told you one basic aspect. I'm sorry. If you have more air particles, okay, if you have more air particles, whenever you have more air particles, we say there is high density, right? We also say there is high pressure. Yesterday I told you, whenever you have low density, you will have low pressure. Okay. Yeah, high temperature, low temperature. I'm sorry. Now, everyone, look at this. The first basic point I want you to know is this is Earth's surface. Closer to the Earth's surface, you have lot of air particles. As you move above, number of air particles are less. Okay. So now, everyone, look at this. Let us assume that this much of the earth is heated. Okay. Let us assume this much of the earth is heated because of sun's rays. Sun's rays fell on this. This much of the earth got heated. Can you people tell me, if earth is hot, air above the earth, will it also be hotter? Tell me, air above the earth will also be hotter? Yes. What will happen to the hot air? What will happen to the hot air is, hot air Can we say that the hot air begins to rise? They rise up, correct? Yes. Now I want you to tell me, in this area, okay, do you have more air particles or do you have less air particles? Less air particles. Everyone? Less air particles. Why is it less? Because it is moving above. Yes. You tell me, guys, if you have less air particles, will it be low pressure or will it be high pressure? Will it be high pressure or low pressure? Low pressure. So you will have low pressure. Do you all agree with me? Why do you have low pressure? Because earth became hot. Whenever earth becomes hot, air above the earth will also become hot, and the hot air rises. As hot air rises, near the hot surface, air particles will be less. As air particles will be less, we will have low pressure area. And guys, can you tell me this part and this part, this part and this part? Here, can I say you have more air particles? Can I say you have high pressure? You have more air particles here. Can we say you have high pressure? Yes. Okay. Can we say that high pressure is on both sides? Okay. High pressure is on both sides. Low pressure is here. Now, let us assume that we have two tumblers. Two tumblers. One tumbler, you have more water. Second tumbler, you have less water. Okay. Now, when you connect these two, this is A, this is B. Okay. If you have more particles, I will call it as high pressure. If you have less particles, I will call it as low pressure. Okay. Can you tell me movement will be from where to where, guys? Movement will be from where to where? A to B. Okay. You tell me, is there any possibility of water or air moving from B to A? No. So can I say air, wind, everything will move from where to where? High pressure to low pressure. Please check this now, guys. In this particular diagram, can I say the wind will blow from high pressure to low pressure? It will blow from high pressure to low pressure? Yes. When it is blowing from high pressure to low pressure, can I say earth is hot? Please tell me again. Is earth hot? Yes. If earth is hot, will it heat the air again? If earth is hot, will it heat the air again? And can I say the hot air rises again? Hot air rises again. So what are the two things happening here, guys? The two things that are happening here is air is converging air and rising air. Do you all agree with me? Is there converging air? Is there rising air? Yes. Cyclones and all are formed like this only. It's true. So can we say converging and rising air? Okay. So in geography, from now on, I want you to remember a particular thing. That is, okay, low pressure is equal to converging air and rising air. You see, from high pressure to low pressure, air is converging. From high pressure to low pressure, air is converging. Okay. Yes. Get created into high pressure, Faiza, it's correct. But can I say earth is hot? Again, earth will heat the air and the hot air rises. Okay. So you see, I want you to write down first low pressure. Low pressure means converging and rising air. Okay. And there are two types of low pressure. Two types of low pressure. One is thermally induced. Second is dynamically induced. Okay. What is low pressure? Converging and rising. What is converging? Air is converging. You see, air is converging and air is rising. Okay. Now in this area, if I have low pressure, air converges and air rises. Okay. So that is called converging and rising air. There are two types of low pressure. One is thermally induced low pressure. Another one is dynamically induced low pressure. Now, in this, the first one is thermally induced. It's converging. Converging means air coming closer. Air coming closer is called converging. Okay, nothing much. If air is coming closer, it is called as converging. Okay. So you take this particular part of the earth is hot. Why is it hot? Because of sun rays. Because of sun's rays. Okay. This is hot. As the surface is hot, air will rise. As air will rise, there will be low pressure. But in the surrounding, you will have high pressure. Wind always, okay, Gia, please see, wind always blow from high pressure to low pressure. Wind always blow from high pressure to low pressure. That's why it is converging. Okay. Wind always blow from high pressure to low pressure. That is why it is converging. Fine. Okay. Now, why is it rising? Why is it rising? Because air is getting hot. So you write here, whenever Earth's surface is hot, air above the Earth's surface is also hot, and hot air rises. Okay, hot air rises. Okay, see guys, why low pressure is present at one place only? I am assuming, okay, I'm assuming that sun's rays is heating only this much. Okay, this can be 1,000 kilometers, this can be 2,000 kilometers. Okay, is also hot, and hot air rises, and this leads to low pressure. This leads to low pressure. I'll move to next slide, guys. As low pressure is formed, air from the surrounding high pressure would reach low pressure. It is heated again, and the hot air rises again. So, wherever Earth is hot, we observe converging and rising air. Okay, so this converging and rising air is called as low pressure. Fine, this is thermally induced low pressure areas. Yes, so now let's see second one, that is dynamically induced. Okay, now guys, if I have cold air, okay, and if you have warm air, and let us assume that cold air and warm air is converging. See guys, please don't ask why cold air and warm air is formed. Assume that there is cold air and there is warm air. Okay. Now you tell, when cold and warm air hits, okay, which one will rise, guys? Which one will rise? When cold and warm hits, which one will rise? Warm will rise. Why? Warm is lighter, cold is denser. Okay, as cold and warm meets, warm air rises. Okay, so now the point is, if warm air rises, if warm air rises above like this, okay, can you people tell me, this is your warm air. Warm air is rising. Okay. Denser means weight is more now. Okay. So when it rises, when warm air rises, you tell me, in this particular part, will you have more air particles or will you have less air particles? Will you have more air particles or less air particles? Less air particles means low pressure. Okay, guys, first understand the complete concept. I will be revising them again and again. Okay, then I will make you write. Even after writing, if you don't understand, raise a question. Else, you will be always thinking about what question to ask. Okay, we will answer all the questions that you have. We are here, we are paid for that, so don't worry about it. But the point is, first try to understand what is it. Okay, so what is happening here? What is happening whenever cold and warm hits? Okay, I have a simple question. Mobile and pen. Okay, mobile is heavier, pen is lighter. When mobile and pen hits, okay, which one will rise? The pen will rise. When car and bike hits, bike should rise, or truck and bike hits, bike should rise. Okay, so that is warm, cold and warm. Truck is like cold and warm is like bike. When they both hit, which one will rise? Warm will rise. When warm is rising, normally in that particular part, you will have less air. As there is less air, we call low pressure. And can you see here what is happening? Air is converging. Air is converging. And warm air is rising. Correct? Air is hitting, warm air is rising. This is called dynamically induced low pressure. So what is this dynamically induced low pressure? When warm and cold air converge, warm air rises. Warm air rises and creates low pressure area. You may ask, sir, why are we calling it dynamically induced? Okay. Now you see this particular part. Okay. You see this particular part. If you have this particular part, if you have this particular part, is it cold or is it hot? Is it cold or hot? Okay. It may be cold, it may be hot. Okay. It may be cold, it may be hot. We don't know. It can be either cold or it can be hot. Irrespective of whether it is cold or hot, it will rise. Okay. If it is hot, it will rise. Then it is thermally induced. You see, if land is hot and then if air rises, then it is called thermally induced. If land is either hot or cold, doesn't matter, but air converges, and after converging, if it rises, we call it as what? Dynamically induced. Okay. Yes, thermal means hot. Yes. Thermal always doesn't mean hot. Thermal means temperature driven. Okay. Thermal means due to temperature. Fronts and all will come later. Okay. Now, I hope you people wrote this. Guys, all the slides written will be given to you. No need to worry about it. Sixth one. Air converges due to wind movement. Guys. No need of sunlight. Even in the night, air moves. Yeah, cold air slowly comes to that place. See guys, one thing, please stick to what we are seeing. Don't think beyond that, what will happen after warm air comes and all. That we will read over a period of time. I'm teaching you basic concepts. I'm teaching you low pressure. In low pressure, I'm telling you two words. Okay, please understand this. What is a low pressure area? What am I trying to tell you? And what is asked in the exam? Okay, in exam, they will ask you, wherever there is low pressure, what do you observe? Okay, wherever there is low pressure, what do you observe? We observe converging and rising air. Okay, what are the two types of low pressure area? Thermally induced, dynamically induced. That's it. They won't ask you beyond this. Explanation of thermally and dynamically I gave you so that you will understand the concept. As of now, I want you to remember only one thing, that is low pressure basically means converging and rising air. Okay. Second is, we talk about high pressure area. High pressure area. Okay. Now, you see, what is this high pressure area? Whenever you have air particles. Okay. Now let me assume that this part is cold. Okay, this part is cold. Whenever this part of the earth is cold, what is going to happen? This entire air will become cold. Okay, and all the cold air will become heavier. Cold air becomes heavier, and as cold air becomes heavier, they all start coming closer. Now you tell me guys, if more air particles come closer, okay, will you have more air particles? How Earth becomes cold? You tell me. Poles, is sun's rays less? Poles, is sun's rays less? If sun's rays is less, will you have cold surface? Huh. Okay, see, if sun's rays is more, surface will become hot. If sun's rays is less, surface will become cold. You tell me winter season, Delhi is cold. Summer season, Delhi is hot. Why? Because of sun's rays. Okay. Now, you tell me when you have more air particles, you tell me here A, B, C. Where do you have more air particles is? Yes. So, can I say in this region you will have high pressure? Can I say wind will blow from high pressure to low pressure, everyone? Yes. Can you tell the two things that are happening here, everyone? Can you tell two things that are happening here? One, is air rising or is air descending? Is air rising or is air descending? Descending. Good. Descending air and diverging air. Okay? Yeah. See guys, when air particles come closer, definitely temperature increases. But by that time, it will spread out. Okay? Air particles come closer and spreads out. You see, I'm not talking about surface temperature. I'm talking about air. So don't get confused. Here the simple point is high pressure basically means descending air and diverging air. Yeah, this is under climatology, guys. Yeah, high pressure basically means what? Descending and diverging. Okay, low pressure basically means what? Converging and rising air. Now, now, can you? I hope you people drew this. I hope you people drew this. Yes. Now, now. See guys, all this we are studying under the heading of climatology. These are all basic concepts that I'm trying to cover under climatology. Okay. So the basic question that I will ask you now, what do you observe in subtropical high pressure area? What do you observe in subtropical high pressure area? Okay, high pressure. Everyone, can you tell me what is it that you will get? What is it that you will get? Descending and diverging. See, always you people are confused about other words. I am asking, forget about the question. High pressure means what? Descending and diverging. That's it. Right? So high pressure, anywhere in UPSC, if they ask you, you should say it is descending and diverging. Okay. So let us say they ask a question, subpolar low pressure. What is subpolar low pressure? What will you tell? What is low pressure? What will you tell? Converging and rising air. Very good. Ascending and all, don't write this. Ascending, no, no, no. See, wrong terms don't use. Don't use wrong terms. You use converging and rising. I don't want you to give your own terminologies, guys. These are basic concepts where you should give proper terminologies. Okay? Okay. So see, any time in future when I ask you, if I tell high pressure, you should tell me descending, diverging. If I tell you low pressure, you should tell me converging and rising. Second thing, I want you to tell me when earth surface when earth surface is hot, when earth surface is hot, what do you observe is, when earth's surface is hot, what do you observe? Guys, subtropical, subpolar, I will explain future, don't worry. Okay, in future I will explain you, don't worry. Whenever earth's surface is hot, you will get low pressure. Good. When earth's surface is cold, what do you get? High pressure. See guys, this page, write it separately, paste it somewhere. This is the most important topic. Okay, see, there are two ways. Even once when we don't understand the concepts, it's better at least for us to remember the words. Okay, no, don't use sinking and all, use descending and diverging. Yes, make sticky note of this, keep this with you. Okay, this should be handy for you in next classes. Okay, now guys, I will teach you one topic again under climatology only, another basic concept. Okay, every year from last 10 years, one question has come on this topic for sure. Okay, on this topic you will get one question for sure. So please ensure you are understanding this carefully. This is, heading is heat transfer in atmosphere. Heat transfer in atmosphere. Below this, another heading, conduction. Guys, this is for prelims, guys. Convection, radiation, reflection, and advection. Mandatory one question is coming from this particular topic every year, guys. 6th and 7th standard NCERT, they have this basics. Okay, they have this basics and you should be aware about it. Okay, now first we will take up conduction. Okay, yes, first let me explain this concept. You tell me, are human beings good conductor of heat or bad conductor of heat? Human beings, we human beings, good conductor or bad conductor of heat? Many people are giving both good and bad, fine. Are we good or bad conductor of electricity? Are we good or bad conductor of electricity? Okay. First of all, what is conduction? Okay. Now let me say, everyone, yeah, you see, I will go and touch electric power. Okay. Anywhere, I'll just go and keep my finger. The electrons will pass through me. Okay, someone will come and touch me. Someone will come and touch me. I will get electric shock. He will also get electric shock. And if someone comes and touch that person, he will also get electric shock. That means when we are in contact, there is movement of electrons. Okay, when we are in contact, there is movement of electrons. That is called good conductor, and human beings are good conductors of electricity. Okay, human beings are good conductors of electricity. This is the first point. What is the second point? See, second point is, now I will go and touch a hot object. Okay, I will go and touch a hot object. Wherever I touch, let us say this is hot, I touched it. What is going to happen? My hand will burn, right? My hand will burn. And here nothing happens to my another hand, only this part will be burnt. And if someone comes and touches my hand, if someone comes and pushes me, whatever they do, nothing happens to them. Correct? Nothing happens to them. Only my hand will be affected. There is no spread of heat to the other parts. Heat is not spreading from the hand to other parts. That means it is bad conductor. Okay, it is bad conductor. Fine. Now my point is, human beings are good conductors of electricity, bad conductors of heat. I want you to tell me, okay, this is a candle, guys. This is a candle. If I'm closer to the candle, my hand will burn. If I move away from the candle, okay, if I move away from the candle, the burning effect reduces. Do you all agree with me? If we move away, the burning effect reduces. That means let us say, if earth is there, okay, if earth's surface is hot, everyone, if earth's surface is hot, I will take two layers. I will take two layers, A layer and B layer. Okay, A layer is close, B layer is far. Can you tell me, if earth is hot, which layer will become hot and which layer will become cooler? A will become hot, B will be cooler. Good, good. Can you tell why A is hot? Can you tell why A is hot? Is it radiation or is it conduction? What is happening is, what is happening? Conduction. Huh. See, you tell me, whenever we touch any hot object anywhere, if I go and touch a hot object like this, it will affect me. That is called as conduction. Okay. Yes. Guys, you tell me now, it's very cold. I will rub. Due to friction, heat is generated. Okay. Heat is generated. And then I'll touch. Can I say, when I touch, the heat from my hand will touch my skin? That is called as conduction. Okay. When conduction occurs when there is contact. Can you tell me this now? You tell me here. I have a surface. This part of the earth is cold and this part of the earth is hot. Okay, I'm assuming, guys, this is hot, this is cold. Okay, can you tell me what will happen to the air above? What will happen to the air above? Here I will get cold air. Here I will get hot air. Yes? Huh. Don't worry about high pressure, low pressure and all. I'm just trying to talk about heat transfer. Heat transfer. See, air is bad conductor of heat, correct? But wherever there is contact, I told you, human beings are also bad conductors of heat. But when it is hot, when something is hot, and if I keep it, it burns. Okay, that means wherever air touches hot surface, wherever air touches cold surface, that particular part you will have heat transfer. So prelims question and topic for you also to write this down under conduction. Under conduction, write this: conduction in atmosphere occurs only near the earth surface. Conduction in atmosphere occurs only near the earth surface. When earth surface is hot, air above will become hot. When earth surface is cold, air becomes cooler. Yes, as air is in contact with the earth surface. Yes. Shardanjali, you're right. Okay. Did you write this? You will get the slides even if I'm moving faster. I'm only writing slow. Okay. Next is above. We saw conduction. Okay. Conduction. Next, we have convection. Convection. Okay. See, conduction. Another point here in conduction. Conduction occurs in solids more ways. Air is bad conductor of heat. Air is bad conductor of heat. Next, convection. Okay. Air only in contact will transfer the heat. If not in contact, it will not. Okay, guys, don't get into why air is bad conductor and all this. That's not required. Different particles will have different properties. Guys, now I am heating a tumbler of water. Can you tell me which one will become hot? Which one will be cooler? So A becomes hotter first and B will be cooler. Okay, okay. A is hot, B is cold. Okay. Can you tell me which one is heavier? Which one is lighter? Which one is heavier? Which one is lighter? B is heavy, A is lighter. Correct. Which one will come down? Can I say B comes down? B comes down and A rises? And A rises? Can we say there is vertical movement of air? Can we say there is vertical movement of air? Yes. Vertical movement of water, vertical movement of air is called convection. Okay? Vertical movement of air, vertical movement of water is called convection. Okay? Yes, please understand. Whenever cold is above, warm is below. Cold is weighter, that means heavier. Heavier one will come down, lighter one will come up. If you are not understanding, think in this way. If you have a rock, you put it in water. Okay, when you put rock in water, water rises, rock will go down. Correct? So if you have cold and warm, cold comes down, warm rises. Why cold comes down? Due to gravity. Due to gravity, heavier objects comes down, lighter objects move up. That is the phenomena. Now you tell me the other way that we have. Whenever we heat from above, okay, I heated from below. Now I am heating it from above, A and B. Can you tell me which one will become hot soon and which one will take time? B will be hot, A will be cold. Good. Yeah. Can I say, guys? Can I say here one basic point? Cold is heavier and it is already present down. Cold is heavier and it is already present down. And hot is above. Yes. You tell me, will there be vertical movement or no vertical movement? Will there be vertical movement or no vertical movement? So there will be no vertical movement. Okay, please draw this two, guys. Please draw these two. I will give you a phenomena that you have to remember. Okay, first draw this, then I will give you a phenomena. Okay, okay, that wrinkle structure is fire, guys. Sorry. Ma'am, no vertical movement. Why? You only tell. You only tell. Hot air is above, cold air is below. Hot doesn't come down, cold doesn't rise. Cold is heavier, okay? So rock doesn't come up, water doesn't go down. As simple as that. If we heat from side, don't worry. I'm considering only these two. How possible to heat at the top? Sun. Sun heats from top. Do you agree? Earth heats from bottom. Sun heats from top. River and all very less vertical movement. Yes. If you are in hostels and if you are using coil to heat, you might have seen that above water will be hot but below will be cooler. Okay, guys, is this done? Is this done? We are not interested in your water heating phenomena here. Yes. Huh. 6. What I want you to write down, this is very important, okay? Whenever we observe hot air above and cold air below, that is with increasing height, if temperature increases, then there is no vertical movement. Then there is no vertical movement. With increase in height, if temperature decreases, that is cold air is below and warm air is above, then there is vertical movement. If there is vertical movement, then it is convection. Yeah, sorry. Warm air is below and cold air is above, then there is vertical movement. Sorry. If there is vertical movement, then it is convection. Guys, again, this is extremely important for you. Questions have come on this. It will come also. Okay? In exam, if it is confusing, if you are not able to understand the linings of the question paper, I want you to draw this and come to conclusions. Okay? In exam, if it is confusing, draw this and come to conclusion. Then it would be easier. Ma'am, in this phenomenon, Ananya, this is the phenomenon. Okay? Okay. You see? Just remember this. As we go above, if cold water is there, cold air is there, cold comes down, warm rises. Okay? If we go above, if hot air is there and cold air is below, then what is going to happen? No vertical movement. That's it. Yes, ma'am. This helps in other topics also. Done? That is if temperature decreases. Okay? In the first statement, I have given if temperature increases. In second statement, I have given if temperature decreases. See, first statement is this diagram. Second statement is this diagram. Okay. Next is radiation. Height means altitude. Height means altitude. It's just a simple thing, guys. I don't know why you are getting so much confused. You see, whenever at home, you take a tumbler, heat it from below on the stove, water you keep a plate above. Have you seen, like, the water will circulate like this. The plate keeps moving up and down. That means there is vertical movement. If there is vertical movement, we call it convection. Okay, that's it. Radiation. Okay. By understanding the level, I'm just trying to tell you a few things. Okay, please understand this carefully. Radiation. Now, you tell me. I will take a hot cup of coffee or tea. Okay, it is hot. Okay, what I'll do, I will keep it out. I will keep it out. You tell me, after some time, will it slowly reduce? Will it slowly become cooler? Yes. Yes. So can we say that it releases heat to the surrounding? Yes. Okay, if temperature increase with height, if you're not clear with that, if temperature increases with height, if temperature decreases with height, that is the point. Okay, yeah. Now you tell me, I have an ice cube, guys. Ice cube, which is at 0 degrees Celsius. Outside temperature is 20 degrees Celsius. And it is in the night. Okay, it is in the night. Not even day. Okay, night. Okay. Now you tell, if I take an ice cube and keep it outside for some time, can I say the ice cube will try to become water? Yes. Yeah. Can we say that ice cube will absorb heat from the surrounding ice? Can I say the ice cube will absorb heat from the surrounding? Yes, yes. You see, what is this? Every hot object, radiate its heat to the surrounding. Second, you tell me guys, sun. Does sun has its own heat? Is sun hotter? And why is sun hotter? Because of nuclear fusion, correct? In the sun, there is nuclear fusion. Because of nuclear fusion, can I say sun is hot? Okay, you tell me, can the sun's rays reach the earth? Are we in contact? We are not touching the sun, but still the sun's rays is coming and hitting the earth, correct? So even when two objects are not in contact, if there is heat transfer, we call it as radiation. Okay. Is this clear? Guys, Lakshmi, don't get into other topics. As of now, just focus on this. See, when there is contact, we talk about conduction. If it is not in contact, we call it radiation. Okay. You please guys, let's not get into nuclear fusion and all that. You will get in other science and technology. Now, you see, whenever I take a hot object, any hot object would release its heat to the surroundings. Chanchal, human body, all those things were examples. Please don't get into those concepts. Please understand from atmosphere point of view. Okay. See this. Now, 100, 80, 60. Surrounding is 30. Okay. Now, can I say 100 degree will release how much heat it is? 100 degree will release till it becomes 30 degree. That means 100 will release 70 degrees Celsius. 80 will release 50 degrees Celsius. 60 will also release 30 degrees Celsius. Okay, fine. So now please understand this basic phenomena. See this. Now, it has to release how much? 70. It has to release how much? 50. It has to release how much? 30. Okay. Now guys, you tell me, if at all I need to go from A to B faster. I have to go from A to B faster. Straight line is the case. If I have to go from A to B slower, what will I do? I will go like this. If there is a slow race, I will go like this. If there is fast race, I will go like this. Okay. 100 is hotter. Okay. So what happens? 100 will release heat faster. 60 will release heat slower. So in conduction, the basic principle is, see guys, this is called wavelength. This is called wavelength. And if you look at it, the basic principle is hotter the object, shorter is the wavelength. Hotter the object, shorter is the wavelength. Cooler the object, longer is the wavelength. I want you to think now and tell me, I have earth and I have sun. Can you tell me among earth and sun, which is hot? Among earth and sun, which is hot? Sun. So you tell me here, whatever comes from the sun, will it be short wave or will it be long waveless? Whatever comes from the sun, is it okay? Guys, please don't get confused with high pressure, low pressure and all. I'm not talking about high pressure, low pressure. Please listen to what I am talking. Don't relate by your own. Okay, I'm talking about heat here. So from the sun, whatever comes is short wave. It is called as incoming short wave radiation. Okay, and it is called solar insolation also. And in this, guys, you will have like 50% of visible light, 10% of UV, okay, and 40% of infrared. Okay, solar insolation is called as incoming short wave radiation. Within the solar radiation, we will have visible light, we will have UV, we will have infrared also. Okay, guys, don't get into this short wave, long wave. I'm just trying to tell a basic thing. Remember only that hotter the object, shorter is the wavelength. Cooler the object, longer is the wavelength. Okay, infrared, yes. Ultraviolet, okay. Now you tell me from the earth, from the earth, whatever goes out. No need of wavelength definition and all, guys, please. Whatever goes out is called as outgoing long wave terrestrial radiation. Outgoing long wave terrestrial radiation. Okay. Guys, what are the 2 points? Whatever comes from the sun is called as incoming solar radiation. That is called as short wave radiation. I don't know if you people are aware. You see, from the sun, we get UV, which is very, very small. Little bit you get like this. This is visible light. And you get like this. This is infrared waves. Okay. And this is responsible for light. Sunlight, light, this is responsible. And this is what you call as Vibgayar. Infrared waves. This is responsible for heating. UV is dangerous. UV is dangerous and it is absorbed by ozone. Okay. This basic concept is very, very important for you. Okay. Prelims question. Which rays of the sun is leading to heating of atmosphere? It is infrared. Okay. Yeah. Most of the UV rays is absorbed, not all. Vibgayar are the colors, this. What to write? Okay. You wrote this? You wrote this page? Yes. You wrote this? Yes. Yes, ma'am. Ozone depletion will lead to more UV rays. Terrestrial radiation means radiation from the earth. Terrestrial, anywhere, means earth. Okay? In geography, terrestrial means earth. Vibgayar are colors. Rainbow. Have you heard rainbow colors? They are your rainbow colors. Violet, indigo, blue, green, yellow, orange, red. Okay. Uh, some people might be advanced, but I'm getting a lot of questions. So as it is first two questions, things. Climatology is little technical is when we enter into different topics. And if you look at the depth in which UPSC is asking questions, I have to explain this. Okay, one of the main reason what is happening is climate change, global warming. Due to global warming, all these concepts have become extremely important for UPSC. That's the reason I am also showing you these aspects again and again. Okay, there's nothing much to explain solar insolation. Sun is hot. As sun is hot, hot object will radiate heat. As sun is very hot, it will radiate short wave. So whatever comes from the sun is short wave radiation. Okay. So now, ma'am, this is climatology only. This is not something else. Climatology basics I'm covering. The Nilanjana, no need of all other rays. These three rays are enough. Okay. So guys, now with respect to radiation, I want to explain few concepts, guys. What is radiation? First thing is every hot object radiate its heat to the surrounding. This is what we wanted to see. Okay. Now, everyone, please understand this concept clearly. Earth. I have ozone. Okay, ozone. Clouds. Carbon dioxide. Oxygen. Nitrogen. Water vapor. Okay, I have these things. Now you see, when sun's rays will come, when sun's rays will come, okay, can you people tell me, can you people tell me, when sun's rays will come, ozone absorbs which part of the sun's rays? Ozone absorbs which part of the sun's rays? UV. Good. Huh. Guys, have you seen whenever clouds are present in the sky, whenever clouds are present in the sky, have you observed below that we don't get sun's rays much? Yes, sun's rays much. That means all the sun's rays, all the sun's rays that falls on the cloud is sent back. Okay, all the sun's rays, ma'am, that is property of ozone. Okay, that is property of ozone, right? Now clouds reflect everything. Carbon dioxide doesn't absorb sun's rays. Carbon dioxide doesn't absorb sun's rays. Oxygen, nitrogen doesn't absorb sun's rays. Okay, oxygen, nitrogen doesn't absorb sun's rays. Water vapor absorbs sun's rays. No, carbon dioxide doesn't absorb sun's rays. Okay, oxygen, nitrogen doesn't absorb. Water vapor absorbs. Okay, water vapor absorbs. So please understand, when sun's rays is coming, you tell me, if clouds are there, clouds are above, you are below the cloud, will you feel cooler? Everyone, will you feel cooler below the cloud? Yes. Guys, oxygen and nitrogen forms 99% of the atmosphere. Gases, if you take, oxygen and nitrogen forms 99%. Now my question to you is, if 99% is not absorbing sun's rays, can you see 99% is not absorbing sun's rays? This is the reason sun's rays is reaching till the earth. You see, sun's rays is reaching till the earth. If oxygen and nitrogen absorb sun's rays, then it wouldn't have reached the earth at all. Okay, so you tell me, among all this, which is the main gas which is leading to increase of temperature? Among all this, which is it that is increasing the temperature? What is it? Water vapor. See, ma'am. Okay, Zarana, see. Atmosphere is made up of oxygen and nitrogen 99%. 78% of nitrogen is there, 21% of oxygen is there. Atmosphere has 99% of oxygen and nitrogen. And this oxygen and nitrogen doesn't absorb sun's rays. Carbon dioxide doesn't absorb sun's rays. Clouds are not absorbing sun's rays. So the only thing that is absorbing sun's rays is ozone and water vapor. Ozone and water vapor. So now you tell me, if water vapor is more, will you feel more heat or will you feel less heat? If water vapor is more, will you feel more heat or less heat? More heat, not less heat. Okay, some people are getting confused. I'll explain this. You see, now you see earth. Okay, now you see ozone, clouds, oxygen and nitrogen, water vapor, carbon dioxide. Okay, guys, Earth's radiation is long wave radiation, means it is sent back. Long wave is sent back. Oxygen, ozone, nothing absorbs Earth's radiation. Water vapor absorbs Earth's radiation. Carbon dioxide absorbs Earth's radiation. So guys, you tell me, carbon dioxide and greenhouse gases, what do they absorb? Earth's radiation or sun's radiation? Carbon dioxide and water vapor, do they absorb earth radiation or sun's radiation? Earth radiation. Good. So what is greenhouse gas? What is greenhouse gas? The gas which traps outgoing Earth's radiation is called greenhouse gas. Okay, the gas which traps outgoing Earth radiation is called as greenhouse gas. Is this clear? Okay, guys. Radiation. I will explain again. Take break first. 6:47 will meet. Okay, 6:47 will meet, and then we'll talk. Yes, greenhouse gas is mixture of different gases. Correct, guys. Water vapor also traps. That's why water vapor is called as, like, what do you call as? It is natural greenhouse gas. Okay. Yeah. Cloud is what you see in the form of white color. Humidity, water vapor is humidity. This one, this slide, guys. Okay. See guys, uh, the structure of the class is, first I'm teaching you certain basic concepts. Okay, what we are dealing is climatology itself. Within climatology, we need to talk about geoid shape of the earth. If I don't understand geoid shape of the earth, I won't understand many topics associated with it. Second, I also have to deal with what we call as atmosphere, pressure, temperature, because these are the basic concepts from which questions repeatedly come. So, as of now, I am dealing with the basics of atmosphere chapter itself. So, within climatology, we are seeing certain basic concepts. If you feel you know these basic concepts, I can directly enter into atmosphere and teach you what is there in the books. I am giving you these because questions are coming from these aspects. Clear? So, the point is, see, you are also writing along with me, no? What is the use of writing them before itself? Yes. Now, guys, I want you to I want you to understand some basic things here. I want everyone to write this down. Okay. You see now, under radiation only write this. Ozone. Ozone. What does ozone do? Ozone absorb incoming incoming solar radiation. Okay. But even in the incoming solar radiation, it will absorb only UV rays. Okay, it will absorb only UV rays. Which one? Ozone. So, second, oxygen, nitrogen, which forms 99%. Okay, it doesn't absorb, it doesn't absorb solar insolation. See guys, insolation of the sun and radiation is same. And also doesn't absorb Earth's radiation. Okay. Next. Greenhouse gases. Yesterday I told you 6 or 7 greenhouse gases. Do you all recollect that, guys? Do you all recollect those 6 or 7 greenhouse gases? Carbon dioxide, methane, yes, nitrous oxide, perfluorocarbon, hydrofluorocarbon, sulfur hexafluoride, nitrogen trifluoride. Okay, these greenhouse gases doesn't absorb solar insolation but absorb Earth's radiation. Okay, last. Water vapor. Water vapor absorb both solar insolation and Earth's radiation. Absorbs both solar insolation and Earth's radiation. Now, that is the property. Neelanjana, that is the property of water vapor. Yes. Earth also releases the heat to the atmosphere. I'll come to clouds. I'll write about clouds. You wrote this? Okay. Fine. See guys, if at all the white color that you see is the cloud, and water vapor that exists in the atmosphere, moisture that exists in the atmosphere is water vapors. Clouds. Yes, clouds has a specific property. Okay, clouds has a specific property. I want you to write them. This has been asked in the exam and it will be asked again also. So I will explain more when it comes to clouds topic. We have clouds topic also, but under reflection radiation, I want you to write this down. Okay. Low altitude. Altitude means height. Low altitude, thick clouds reflect solar radiation and cool the earth surface. High altitude, thin clouds allow solar insolation. I told you solar insolation and radiation both are same. Allow solar insolation but trap Earth's radiation. Okay, but trap Earth's radiation. High clouds increase Earth's temperature. I'll explain this later, guys, but I want you to know this. This is prelims questions. Greenhouse gases are present in troposphere. Insolation means radiation. Sun's radiation is called insolation. Okay. It's very, very important, guys. Clouds, as I told you, I will explain once again. Don't worry about it. As of now, just write it, okay? We have clouds topic. There we will see clouds in details. Yes, yes, yes. That's what I will explain this high clouds, low clouds and all. Don't worry about it now. As it is asked in the exam, I wanted you to have this. Later I'll explain you this concept. Okay. Guys, no, not isolation, insolation. Not insolation and radiation are same. Okay. Guys, do you understand why it is called greenhouse gas? Why is it called greenhouse gas? Okay. Greenhouse chamber. Yes. Guys, I want to ask you, have you seen when you have a car outside? Okay. When you have kept a car outside, have you seen inside the car temperature increases? Have you seen hot sun, if you keep, have you observed temperature increases? Yes. Now you see what happens. Okay. People in Norway, Sweden, Finland, that is closer to the poles. If I go closer to the poles, what is happening? Sun rays is less. As sun's rays is less, they feel very, very cold. Okay, they feel very, very cold. Now, what they saw inside the car, when they keep car outside, it is little hotter inside the car, but outside it is cooler. They wanted to know what is happening inside the car. At that time, what they found, the glass that is there has a specific property. What is the property? The glass allows sun's rays to come inside. From all the sides, sun's rays would come inside. Okay? And it will heat inside. Okay? It will heat inside. Once it heats, as you know, okay, morning sun's rays will come. Okay? Evening, night when sun is not there, what will happen? This will release long wave radiation. Now you tell me, this long wave radiation, it is not going outside this glass chamber. Can I say it is trapped inside? Can I say it is trapped inside? Yes. So see, the glass has a property. What is the property of the glass? It will allow incoming sun's rays, but it doesn't allow long wave. Okay. Now let me say I am in a closed room. In this room, sun's rays came, and sun's rays will heat the table, chair, everything it will heat. All these objects became little hotter, and every hot object radiates heat. In the night, it has to cool down. It has to cool to the surrounding. When it has to cool to the surrounding, it will release long wave radiation. right? And this long wave radiation is trapped inside the glass house. Okay, as it is trapped, you tell me, will the place inside the glass chamber, will it become little hotter? Little hotter? Yes. As, see, why it doesn't do its property. Okay, as it becomes little hotter, what is going to happen? Temperature increases. As temperature increases, people of Norway, Sweden and all will be happy. Now you tell me, Norway, Sweden, Finland, can they build their houses in glasses? Can they build their houses in glasses? No, they have to build. Why they have to build the houses in the glasses? Only if they build the houses in the glasses, then only the rays will come inside. Okay, and then heat will be trapped. Now you tell me, if I take carbon dioxide, is carbon dioxide absorbing sun's rays, or is it absorbing, like, Earth's rays? Carbon dioxide absorbs which one? Earth's rays. If carbon dioxide absorbs Earth's rays, is it acting similar to greenhouse? Is it acting similar to greenhouse? Yes. So it is called greenhouse gas. Zarana, this glass chamber is called greenhouse. And as carbon dioxide also acts like greenhouse, it is called greenhouse gas. This concept will be explained to you in climate change of environment and ecology as well, guys. But as I am talking about the radiation reflection and all, I thought I will introduce the concept so that when you listen to environment faculty, it would be much easier. Yes. Is this clear? Okay. Now, can you tell me what is the property? Okay. Earth's radiation, if it is absorbed, it will increase Earth's temperature. I'm sorry. Yeah. Earth's radiation, if it is absorbed, it will increase Earth's temperature, guys. Carbon dioxide absorbed Earth's temperature and increased Earth's temperature. I repeat, carbon dioxide absorbed Earth's heat and increased Earth's temperature, and that is responsible for life. So, increasing Earth's temperature is good, but when it increases beyond a point, it is bad. Okay, if it is increasing beyond a point, it is bad. Now, okay, guys, can you tell me? I have a glacier, guys. I have a glacier. Glacier. Okay. I have a mirror. Okay. I have a mirror. Okay. Now you tell me, when something hits on the mirror, can I say it comes back? Do we call it as reflection? Do we call it as reflection? Yes. Now you tell. Glacier means ice, guys. Hariharan, like, certain words, certain terminologies, if it is making you really difficult, let me know. You can contact me. I'll talk to you once, because you're asking certain terminologies. I understand if you are not exposed to this, these may be difficult. Ice, glacier means ice. Okay, you can call. We can have a discussion on all this ones. Now, when you observe that sun's rays will fall, glacier will also send back sun's rays. Okay, can you tell me what is coming? What is coming is incoming short wave. Okay, incoming short wave is coming. What is going out? Can you people tell me what is going out? Is it short wave going out or long wave going out? What is going out? No, 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 no. We are not talking about. Okay. Okay. See, that's why I wanted to ask you. Everyone, wait for a while. Wait for a while. There is some confusion. I will explain you this. Okay. Now, I have ice, glacier. I have land. Okay. I have glacier. I have land. Now, sun's rays will fall on the glacier. Okay. Sun's rays will fall on the land. Okay. Can you people tell me which one will absorb sun's rays? Which one will reflect sun's rays? Which one will absorb sun's rays? Which one will reflect sun's rays? Land absorb, glacier reflect. Okay, good. Glacier reflect. Reflect means it will send back in the short wave. Incoming is also short wave. Outgoing is also short waves. Okay, here you see land will absorb. Land absorb. Mirror. You take mirror. Okay, if mirror is there, if you stand in front of mirror, normal mirror, can I say you will look the way you are? Correct? You won't look fat or thin. You will look the way you are. That means it is reflection. Glaciers will do reflection. And what does the land do? Land absorb. Land becomes hot. And after a while, land will send back. Okay? Land will send back. As land sends back, incoming is short wave, outgoing is long wave. Ma'am, short wave, long wave is like short wave means the wavelength will be small, long wave means wavelength will be longer, nothing much. See, mirror, the way it sends back. Glaciers property is glaciers do not absorb, but it will send back. Glaciers do not absorb, but it will send back. Okay, I will give you another example. I have a white cloth and I have black cloth. Okay, white and black. You tell me, if at all, sun's rays will fall, which one absorbs, which one doesn't absorb? Can you tell? Black absorb, white doesn't absorb. Yes, yes, this is the main reason, like this only. Okay, if you take glaciers, if you take land, glacier property is white color reflects back. Land absorbs, land absorbs, white doesn't absorb, white reflect. Lakshmi, white reflects. Okay. Ha. Do you get the difference here now? Do you get the difference in radiation and reflection? Ha. Gautika has a very good point. Gautika has a very good point. Just a minute. Just a minute, guys. I'll tell you something. Now you see. Okay. This pen is black in color because the pen absorbs all the colors. Okay. If anything absorbs everything, it becomes black. Okay. If at all, let us say something is white, it is white in color because it will send back all the things that are coming. If all the light is sent back, it will appear white in color. These are all properties. Okay, let's not get into detail, but if everything is absorbed, it will appear dark in color. If everything is sent back, it will absorb light in color. Plants, okay, plants normally absorb all the colors but sends back green color. Fine. Plants absorb all the colors but sends back green color. That's why plants appear green. If something is appearing gray, that means it absorbs all the colors but sends back gray. If something is if something is like yellow color, it is absorbing all the colors, it is sending back yellow color. Okay, now see this. Earth is not completely black in color. I'm sorry. Earth is not completely black in color. So, whenever sun's rays will come, okay, let me say sun's rays is 100%. Now what happens? Earth will absorb. I'm giving examples. Okay, example. Earth will absorb 70% and Earth will send back 30%. How much Earth will absorb? 70%. How much Earth will send back? 30%. So this 30% is called as albedo. Okay. What is albedo? Reflected part of the earth is called as albedo. Reflected part of the earth is called as albedo. Okay. Yes, all this is under reflection. I'll give you the heading list. Don't worry. Zarana, that is the property, ma'am. If someone is looking white in color, that means they are reflecting everything. If someone is dark in color, they are absorbing everything. So melanin content in human beings, if it is more, it absorbs sun's rays and it appears dark in color. Okay? Yeah. So guys, now you see everyone, I want you to write down reflection. Okay, when incoming solar radiation, I'll write in bracket short wave, is sent back in the form of short wave, then it is reflection. The reflected part of the sun's rays is known as albedo. No, Anjali, Shardhanjali, no. It is short wave. Only when it goes in short wave, you call it as reflection. If it goes in long wave, you call it as radiation. Please understand this. If it goes in short wave, we call reflection. If it goes back in long wave, it is radiation. So can you people tell me, if land is painted in white color, will there be more reflection, less reflections? If land is painted in white color, will there be more reflection or less reflection? More. If land is painted, if buildings are painted in dark color, will it absorb more? Or will it reflect more? Absorb more. Very good. Okay, now I want you to write along with this below, next point. Dark colors absorb more and has less albedo. Rakesh, that's the property of the colors. That is the property of the objects. Dark color absorb more and has less albedo. Light colors absorb less and has more albedo. Albedo, that is the word used. What is albedo? Albedo is reflected part of sun's rays. Forest, grassland, desert, tundra. Tundra means glaciers, ice. Okay, yeah. Guys, can you people tell me, among this, which one will reflect more? Ice. Okay. Which one will reflect less? Which one will reflect less? Least. See guys, forest you see everyone. Can I say forest absorbs sun's rays for photosynthesis? Can I say forest absorbs sun's rays for photosynthesis? If it absorbs sun's rays, you tell me, if anything absorbs more, will have less albedo, correct? If anything absorbs more, will have less albedo. So prelims question, they have not asked. If they ask you, okay, tundra region has more albedo compared to desert. Desert has more albedo compared to grassland. Grassland has more albedo compared to forest. This you should be aware. This concept should be aware. Yeah, but plants only absorb, no? It doesn't reach the ground. Tundra means poles, polar region. Forest means plants. Plants absorb sun's rays for photosynthesis. That's why it will reflect less. Done? Okay. You see guys now? I'll revise quickly. Conduction. There will be heat transfer. Heat transfer. Where there is contact, and it will occur near Earth surface. Yeah, if you write, it's good. Convection. I'll come to the advection, yes. That's why I'm writing all this. Heat transfer due to vertical movement of air. Conduction, heat transfer due to contact, and it occurs near the Earth's surface. Convection, heat transfer due to vertical movement of air. Radiation, there will be heat transfer even there is without contact. Even without contact, there will be heat transfer. Okay, shall I move to next page? Oh my god. Greater symbol represents albedo, guys. Okay. Then reflection. What is reflection? When radiation. Okay. If I use the term radiation, you may get confused. When short wave is sent back. Okay. Example, glaciers, dust particles, clouds, sulfur dioxide, Okay, guys, you tell me now, if I have dust particles more, if sun's rays is sent back, will it leads to cooling of the earth? That means, will earth be cooler or will it be hotter? Will earth be cooler or will it be hotter? Cooler. You tell me, if you have clouds, okay, will earth be cooler? Yes. Huh. If you have sulfur dioxide, will earth be cooler? If you have sulfur dioxide, will earth be cooler? Yes. Why? Everything is sent back. So, if anything sends back, what is going to happen? Earth will be cooler. So, as temperatures are increasing, we are all suffering, guys, nowadays because of global warming. Human beings are planning for mirrors, guys. This is called geoengineering. They are planning for mirrors. Sulfur dioxide also sends sun's rays back. But that is very minimal. Dust particles trap very minimal, but most of it sends back. Okay. Okay, guys. Carbon dioxide doesn't absorb sun's rays. It doesn't send back. Carbon dioxide doesn't absorb sun's rays. Don't get confused. See the answers, see the topics properly. Okay. What have we told clearly? I have written here. Carbon dioxide, what does it do? Greenhouse gas, doesn't absorb solar insolation but absorb Earth's radiation. Clearly I have written. Don't get confused. Okay. Please sit at home. Please sit at home. You see, some people were asking me, sir, how exactly should we read? Okay. See guys. Now, whatever I am writing on the board, are you writing it down in your class notes? Everyone? Everyone? Yes. Okay. After the class, I want you people to read it once. Will you be able to read it once? Yes. After that, today's topic, read 7th standard NCERT and 6th NCERT. Clearly they have given about conduction and all. Okay. Will you do these two? Temperature chapter is there. Temperature chapter is there. That you see. Only one chapter. Please search for conduction and all. You will get it. You can read, ma'am. Yes. 6th and 7th NCERT online, it's available, guys. Guys, basic questions, basic topics. When I know that questions are coming from this particular area, I am slow. And geography is technical. We don't have scope for jokes and all. It's only topics. So, like, I will cover the syllabus on time for you. Don't worry about it, because we will be trying to understand the concept. Okay. Once these concepts are clear, it's easy for me to understand later chapters. And these topics, you get a lot of questions. That's why I'm worried about it. Every year when something is repeating, see, 90% of the topics in geography, questions won't come. 10% areas questions come. And if you don't read that 10% in depth, you're losing out. It is like if you take ancient and medieval. You see, this is important, guys. If you take ancient and medieval, Buddhism, Jainism, you definitely get questions. So Buddhism, Jainism, you have to spend lot of time. If you take polity, parliament chapter, you get more number of questions. And it's very important for you to read parliament chapter for long. Okay, similarly, economy, money and banking, more questions will come. So you should read more on that. Similarly, when it comes to geography, certain areas repeatedly questions are coming in different languages. That is the reason I'm trying to give you all this, even though it is not there in NCERT. But guys, whatever you are writing in every, in the notes, every line, you need to by heart. You need to remember. Okay, low pressure. What is low pressure? Once I will teach advection, don't worry. Okay, so advection. Sorry, what is low pressure? Converging and rising. Okay, what is high pressure? What is high pressure? Descending and diverging. Descending and diverging. Good. Okay. Last, you see, advection. Okay, see guys, if we have land like this, whenever air, see, air blows horizontally, whenever air blows horizontally, it is called as wind. Okay, fine guys, whenever air blows horizontally, it is called as wind. Okay, now what is advection? Horizontal movement of air is called advection. Okay, vertical movement of air is called convection. Okay, horizontal movement of air is called as advection. Vertical movement of air is called as convection. Okay, nothing much. I hope you got the concept. What is wind? Wind is horizontal movement of air. Okay, you will not say wind rises, we say air rises. Okay, yes, advection also heat transfer includes. Example is land to sea, sea to land, wind will blow. Okay, whenever wind blows from high pressure to low pressure. No. Air itself, when it moves horizontally, we call it as wind. Okay. Water, when it is in a particular area, we call it as pond. If it is flowing, we call river. Like that, air, when it is moving horizontally, it is called as wind. Yes, advection can be there above the Earth's surface as well. Next, guys, next chapter or next subheading, I want you to write down heat budget of the Earth. Heat budget of the Earth. Yeah, air moving vertically is air itself. Advection and wind is synonymous. Yes. Yes, geostrophic wind and all we'll see later. Okay. Heat budget of the Earth is very, very important. Please focus for a while. Okay. Heat budget of the Earth. series. Now, with all the topics that you have covered, let me tell you this. Please listen for a while. Later, you can discuss other doubts that you have. See, this is my atmosphere. Okay, this is Earth. This is your sun. Okay, now when whatever sun's rays would come, I call it as incoming short wave. And geographers have told that let us consider incoming short wave as 100%. Okay, whatever Earth is receiving from the sun is 100%. But you are aware, dust particles, okay, dust particles, glaciers, sulfur dioxide, clouds, everything sends back, okay, everything sends back sun's radiation. I call it as outgoing short wave, which we can call it as albedo, and albedo is 35%. Okay, incoming is 100%, outgoing is 35%. Okay, how much is left? 65% is left. Albedo, whatever is coming, what we sent back is 35%. Both are short wave only. Now what happens? Sun's rays is absorbed by atmosphere. How much? 14%. Guys, do you all recollect? Ozone absorbs UV rays. Can we say ozone absorbs UV rays? Can we say water vapor absorbs sun's rays? Is water vapor absorbing sun's rays? Yes. Is like, ozone absorbing sun's rays? How much is it absorbing? 14% rays. Out of 100, 35 is sent back, 14 is absorbed. Okay, then remaining is 51%. Don't draw, I will give you time. Don't draw now. First see, remaining is 51%. So prelims question, please understand carefully, later you can write. What is that? Out of whatever we receive, okay, whatever sun's rays come, out of that, how much is absorbed by the earth? Only 50%. Okay, these are not actual figures, but this is what NCERT and other books give. Okay, so what I'm trying to tell, prelims question will be, out of the solar insolation received by the earth absorbs only 50% or only half of it. That is correct. Statement is correct. Okay, because it is only 51%. Then in the night, earth will send back long wave radiation, outgoing long wave radiation. Okay, how much is earth sending back? 17% earth will send back. But guys, can I say in atmosphere you will have greenhouse gases? Yes or no? In atmosphere, do you have greenhouse gases? Does greenhouse gases absorb outgoing long wave radiation? Yes. Does greenhouse gas absorb outgoing long wave radiation? Yes. That means it absorbs 34%. That means it absorbs 34%. Yes. So, okay. Guys, everyone, can you see and tell? Atmosphere is absorbing 14% of the sun. Okay, atmosphere is absorbing 14% of the sun, but it is absorbing 34% of the earth. So if that is the case, can you people tell me atmosphere is getting more heat from where? Is it getting more heat from the sun or is it getting more heat from the earth? Is earth giving more heat or sun giving more heat? Earth. Extremely good. This is prelims question, guys. This is prelims question. What is prelims question? Atmosphere gets majority of the heat from the earth, not from the sun. Sun is the major source of heat for earth. Earth is the major source of heat for atmosphere. Are you getting the point? Yes. Now 14 plus 34, it will become 48%. Right? 48%. Now atmosphere will send back 48% to space. Atmosphere will send back 48% to space. Okay. You see, I'll repeat it. How much is incoming? 100%. Okay, how much is incoming? 100%. How much is albedo? 35%. How much is absorbed by the atmosphere? 14%. How much is received by the earth? 51%. You see, 51%. Out of 51%, how much is sent back? 17%. How much is absorbed by the atmosphere? 34%. So 34% plus 14%, you get 48%. Atmosphere also received approximately 50% from the sun and earth together. So atmosphere is getting heated from both sun and earth. How earth is heating? Conduction, convection, radiation, all this comes into picture. Now what atmosphere will do? Atmosphere will send 48% back. Can you all check here how much came? 100%. 48 plus 17 is 65. 65 plus 35 is 100. Whatever is coming, we are sending back. Okay, whatever is coming, we are sending back. This is the core aspect. Hariharan, very good concept. If 48% is sent back, then why are we talking about greenhouse effect and all? See, 48% is not sent back today only. Today, if I receive 48%, I am sending it back after 2 to 3 days. Near poles, okay, you tell me, near poles, if sun's rays will fall on the same day, it will send back. Near equator, tropical region, India and all, if it receives today, it will send back after 2 to 3 days. Because till that time, heat will be there. Heat will be there. Okay. So, that time period is increasing. That is what greenhouse is. Okay. Why time taken? Because of greenhouse gases. Everyone, under heat budget of the earth, can you draw this? Under heat budget of the earth, can you draw this? heat budget of the earth. 34% is carbon dioxide, greenhouse gases, water vapor, which absorbs Earth's radiation. Guys, now do you understand why I explained convection, conduction, radiation, reflection and all? Do you understand this diagram now? Are these simple now for you? No. 51% is divided into two. One is 17%, another one is 34%. Guys, this topic is present in 11th standard fundamentals of physical geography temperature chapter. 11th standard fundamentals of physical geography temperature. Don't go by values, guys. Values of NCERT is different. My values are different. So don't worry about it. UPSC will not ask you values. Okay, UPSC will not ask you values. Can I move to next page? Can I write some points? Atmosphere will release this over a period of time. Kavita, you see, atmosphere is getting heat from the sun 14%, from earth 34%. That's why I'm mixing it as 48%. %17 went to space. Okay, 17% went to space, Simran. 35% went to space. 48% went to space. So whatever we got, we sent it back to space. Space means above 1600. Okay, guys, Gautika has a question. I want everyone to try. When glaciers reflect, then why glaciers are melting? Okay, if glaciers reflect sun's rays, why glaciers are melting? Very good question, ma'am. Very good question. Okay. Now my point is, Gautika, you think and tell me. If I take ice outside and keep it in the night, not in the morning. Okay, sun is not there. I'm talking about morning. Morning when I keep night in a room, closed room. What I'll do, I'll keep an ice. Will it become water? Will it become water? No, don't talk about reflection and all. What I'm trying to say is, think in a very simple manner. Okay. See, sun's rays is not responsible for melting of glaciers. I'll write it down. If you want, I'll write it down. Sun's rays is not directly responsible for melting of glacier. Okay, but surrounding temperature is responsible. Now you tell, if I have an ice and if surrounding temperature is also 0 degrees Celsius, I will have ice. If I have ice and if surrounding temperature is 5 degrees Celsius, ice will become water. Do you agree? Do you agree? Now you understand? Now you understand the concept? Yes, Lakshmi, you're right. Due to global warming, surrounding temperature increases, because of which you get this. Very good, very good. Guys, shall we quickly write them? Please write the points. Only 50% of the sun's rays is absorbed by Earth. Prelims questions, guys. All these are prelims points. Yes, greenhouse gases are responsible. Sun is major source of heat for atmosphere. Sorry. Sun is major source of heat for Earth, and Earth is major source of heat for atmosphere. Solar energy and all are very, very minute, guys. Solar energy, plants and all are very, very minute. Earth sends back almost 100%, not 100%, almost 100%. Okay, geography we don't use 100% is sent back. Some is kept in solar energy, plants, human beings and all. Sends back almost 100% to space. Okay, see guys, today's class pressure concept only notes. Heat transfer concept notes plus 6th and 7th NCERT. Not all chapters, only conduction topic. Heat budget notes plus 11th standard NCERT, fundamentals of physical geography, temperature chapter. What you should do? only heat budget you should read. Don't read everything. Only heat budget you should read. Okay. Sunlight doesn't provide, solar insolation provides. Is this done, guys? Tomorrow I will discuss atmosphere chapter, guys. Fine. Atmosphere chapter we are going to complete, and I will start temperature also tomorrow. Guys, basics are done. We will be doing all these things faster. Kavita, glaciers melt because surrounding heat is more. If surrounding heat is less, that means if you keep in a refrigerator, surrounding heat will be less, glaciers won't melt. Mapping we will do, guys. Okay, guys, previous year questions. I'm giving you the concepts. Okay, don't worry about previous year questions. Every statement that you are writing will cover previous year also, next coming also. Don't worry about it. Hayat, please listen to class from the beginning once, it would be easier. Okay, maps will do, don't worry guys. Maps slowly I'll take one after the other. Gayatri, glacier is not absorbing the heat. Glacier is acting like mirror. Okay, mirror sends back short wave. Mirror sends back short wave. Mirror doesn't send back long wave. Okay, like mirror, glacier also sends back. That's why it is called reflection. If it is going in short wave, we call it as reflection. If it is sending back in long wave, it is called radiation. So glaciers act and give reflection. This mapping I'm not going to do separately. Along with the classes only, I will do mapping. For example, when I teach you temperature, I will talk about equator, Tropic of Cancer, Tropic of Capricorn and all. At that time, I will teach you equator passes through which countries, Tropic of Cancer passes through which countries. Along with the classes only, we will be doing maps. Okay. Long wave means cool, short wave means hot. Correct. Okay. Thank you, guys. Thank you.